Okay, I have batteries here. So it says battery supposed to apply. So here's one, the charger, battery bank, to the transfer switch, and your emergency loads. I'll get back to that one in a bit. But I want to talk about this emergency light. Okay, so I got an emergency light here. This is a weatherproof one. Goes outdoors. Got the cover that goes over the top. Uh, has a battery on it. How long will this battery last with these two lights? Okay, I was looking at the information. These light bulbs are replaceable. They're the M16s or M20s, I can't remember what. And I can replace them. These are 7-watt light bulbs in each one. So I have two 7-watt light bulbs. I've got a 6-volt battery, 4.5 amp hours. So with that, so I got it up here. So I got the two 7-watt lamps. So I got a total load of 14 watts. I have a battery that's 4.5 amps at 6 volts. So in order to get my watts, P equals I times E. So 4.5 times 6 equals 27 watts. Okay. So now I get my battery, which is 27 watts. I divide it by the 14, which is my load. So it gives me 1.9. So this battery would last more than an hour and a half. So this battery would last more than an hour and a half. And it fills in the requirements by the NEC. On storage batteries, where's my code book? I'll get back to that later. So it's got to run for an hour and a half. Alright. So now I also did, I'm going to the battery. So you can see my drawing down here. So I got 3 circuits. So I have a total of 3 circuits that are coming off these batteries. They're 1500 watts, each one at 120 volts. So I get the 1500 watts multiplied by 3. So my total load is 4500 watts. How many batteries do I need? Okay, so in order to find the batteries, this is what I came up with. So I got the batteries, I get the load, I divide it by the volt and amp hour. Okay, the amp hour is like this one up here. This one's 4.5 amp hour. What does that mean? It says, well, it can give me 1 amp for 4.5 hours, or I can get 4.5 amps in 1 hour. That's it. So the amp hours. So I'm going to be using 225 watt batteries. I'll be using a 225 watt battery. So I'll come over here. I'm using a 225 watt battery. So batteries equals the load divided by the voltage times the amp hour. And it gives me the batteries. So I've got a 4500 amp load. So 4500 divided by 12 times 225. They give me 1.7. So I need at least 2 batteries. I need at least 2 batteries at a 12 volt system, so they would be in parallel. Okay, these are all in parallel. But the code says I'm going to need an hour and a half. So what does that have to do? That means I have to double it. So now I'm going to have to double up my system. So now if I need 1.7 for 1 hour, so in order to get it to 2 hours, there's going to be some losses in there. So it's always just wise to up it up. So we go to the 2 batteries. So I'm coming out, here's my source coming in. My standard source coming in. Goes to the charger, goes to the battery bank, then goes to an inverter because I'm running it at 120 volts. I'm not using DC, I'm running at 120 volts. So it goes to an inverter, the inverter changes it from DC to AC, and then it goes out and it feeds these lights. So let's say I got 3 floors and I got emergency lights on the first floor, emergency lights on the second floor, and I have emergency lights on the 3rd floor to light up the hallway, light up the stairwells so people can get out. Okay, so people can get out. It's predetermined. I got a light fixture. It's already predetermined on what the wattage is. Okay, so it's already predetermined what the wattage is. So it's like this one here. I said these are all 7-watt light bulbs. It just lights up the area. People get out of the building. You might have them in some of the rooms. They get out out in the hallway. And they can exit the building. And they got an hour and a half hour, so it gets you. So you size it. Always look at your amp hours. So the wattage output of your batteries, the wattage output of your batteries is your volts times your amps, just like we did up here. Okay. So I'm trying to get my load here divided by the load here. That's all I'm doing. So I'm doing it all in one instead of doing this separate and then dividing it. I can do it here. So here I could have put this, and then I could have put a line and divided by 14. So 4 times 5 times 6, 4.5 times 6 divided by 14, it still would have given me the 1.9. Okay, this is just another way of doing it. Same thing I did on top, just a little bit reversed. So I'm trying to get everything done, and I need to find out how many batteries I need. How many batteries I need to run this load for 2 hours. If we were talking about solar, it would be a completely different thing. So let's say you're doing a house and you want to power a house on solar, so you're off the grid. Okay, this is a charge controller. This is a charge controller. This is one that is a 35 amp. Does 12 and 24 volts. So I can have up to 35 amps to input, so I can put output. Okay. The maximum voltage is 55 amps. So how do I size the solar panel to charge this? Well, what are my batteries? So what do I need to get to my batteries? And what size are my batteries? Guess what? I got batteries that I'm trying to run when I'm trying to use electricity, but I'm also trying to charge them again. So this is a charge controller. This is a small one that I bought to change out on my cabin, because I have lights. That's it. I don't have a refrigerator or anything else with lights, so I bought a small one. Had a $100 credit, so decided to use my $100 credit on the charge controller. Just couldn't buy anything else with it. I got charge controller, so I'll never build my cabin up again after the last one was destroyed. Alright, so this is sizing the batteries. Not hard. It's just a matter of multiplying. Find out what your load is, what type of battery you're using, what's the voltage. Okay, if I was using 24 volts, well, now these batteries would have been in series. It wouldn't have changed voltage. So instead of coming across to feed each one, because you can see each one's in parallel. Because they're coming off, so they're all in parallel. Okay, so now if I was going to put them in series, I'd have a negative coming to here, my positive going to there, and then from here to here I would have gone across. And that would give me 24 volts. 12 plus 12, 24 volts. Okay, it wouldn't change. Okay, it wouldn't change. Because if this is 24, it'd still be 1.7. But if I'm using 12 volt batteries in series, I still need the 1.7. That means I will need 2 series runs at 2 batteries each, 225. Okay, or I can always buy a 225 amp 24 volt battery. They do make them. Okay. So again, this is an emergency light. Pictures come in. This is a bug eye. We call them a bug eye because it's got the 2 lights on it. And what it does is power comes on. If power goes out, power comes on. Okay, these are supposed to be tested regularly, at least a monthly check. So it has a button right here. That's the test button. And when you push the test button, what it does is it goes inside and it turns this on. I got it taken apart right now. But the test button, here's the test button. Pushes that in. The board goes across here. Pushes that in, and the lights come on. So, according to the manufacturers, it says maintenance. This equipment is fully automatic and battery is sealed and lead acid type. No maintenance is necessary. To operate, once you hook it up, the battery will let it charge 24 hours. But also says inspection. National Electric Code and NFPA Life Safety Code requires that routine tests be performed as follows. Once a month, each unit should be tested by interrupting the power supply for at least 30 seconds. That means you go out there and you push the button and you let it come on. See, it comes on for 30 seconds. You make sure it stays on, it doesn't go out. Okay, so that might give you, it's giving you, you're testing to make sure that this battery's still good. You're testing to make sure that this electronic board is still working. Okay? says once a year, each unit should be tested for the full duration of 90 minutes. So that means is if these are on a separate breaker, just like I have them here, guess what? You go turn those breakers off. Come back an hour at, about an hour and a half, hour 15 minutes. Now you start walking the floors to see what one's on and what's not on. Why? Because if it's at an hour, if lights are already going out, that means that the battery is not holding its charge and you're not maintaining this hour and a half. Guess what? These batteries age over time. So as they age, their stay on is less. So if they're not staying on the hour and a half, then you gotta go back and change them out. So just like I did down here, same thing. With this one here, is maybe it's all coming from the same location, and then I can put this, bypass everything, turn everything on. I can bypass, get my charger going, and boom, the lights come on. Okay, so the charger, the power comes in, it goes to the inverter, and I got the power going across. I may have a little jumper coming across to feed these, or whatever it may be, or they're always fed through here. Power goes out, all the charge comes out of the battery. So I can come over here, turn this breaker off. On this one here, I can turn this breaker off. It's going to the charger. What happens? The lights all come on. So I can sit there, look at my clock, or come back an hour and a half. I can walk the floors. How many lights went out? If these all the lights went out, that means that my batteries aren't performing the way they're supposed to. These batteries you have to maintain. You have to clean them. You have to turn around and make sure if you're using a lead acid battery, if you're using the gel cell that are sealed, then you don't have to worry about it. If these are lead acids, guess what? You got to maintain them. You got to check them to make sure that the levels are properly. So always remember, turn power off. It's got to stay on for an hour and a half. If it don't stay on for an hour and a half, you either got to change batteries or change the lights. Okay, you also got to test them to make sure the light bulbs are working. These light bulbs can burn out. These aren't LED. These aren't LED. So these light bulbs can go bad. What do you got to do? You got to go replace them. It's all part of the maintenance to stay within the requirements of the NEC. Okay, all this stuff has to be tested. Oops, wrong way. Okay, I'm going to send an assignment, just like I did this. I'll send an assignment, and I'll send you on batteries. I'll send you a simple one, and I'll send you one like this one, where you have multiple loads. Okay, so, and I'll send you an example. So how do you do that? Okay, so always remember, it's just batteries equals the loads divided by the voltage times the amp hour. So what size batteries you're using, it tells you how many batteries you need. Okay. Emergency power source, getting back, you can have a separate source, a supply tap main, the head of the main, individual unit equipment. Okay, so equipment and batteries, we're talking about the equipment and the batteries, we talk about a separate service. Guess what? You bring two services into your building. You run off of one, and then you have a bypass. In case one goes out, it transfers over to the other. Okay, that's only if you have a problem, let's say the main breaker goes bad. So now it transfers over to the other one till you change the main breaker. That's good. But if utility goes down, well, guess what? You're out of power too. Same thing with a supply tap ahead of the main. You're just bypassing the where it goes to the main breaker and just adding a second main breaker. So if that main breaker goes bad, all you got to do is transfer over to the next one. So instead of having everything out while you change that breaker out, but again, utility goes down, you're all done. Okay, so I got a main breaker. This breaker goes bad. It's always going through this one. If this one goes bad, it transfers over to this one. So that gives me a chance to feed my building, and then until I fix this one. Okay, that's all that does. Lights, exit lights required by OSHA and NFPA in all places of employment. Okay, if you're exiting a room into a hallway, okay, well, one is you got to let them know which way is the out, but they have to get out in the hallway. When they get out in the hallway, you need these exit lights to point them in which way. Okay, so here's an exit light. You kill two birds with one stone. You got an exit light, and it's got the bug lights, so it can light you up. So what does this do? This affords you not having to worry about going back and have to wire batteries in. So you put these in your hallway, just like that emergency bug light that I have. That one you would put it in the stairwell. Guess what? You get one lining up the stairwell, one lining down the stairwell. So you're lighting up the stairwell and lighting down the stairwell. So when people exit, You have one, so you have them at each landing. So your stairwell goes down this way, turns around, goes back down this way. Okay, so you got one here, you got one at the top, you got one at the bottom. So you're lighting up everything as you go. Okay, all you got to do is check and make sure the battery can handle that hour and a half. Yeah, and they don't have to be wired, no generators or nothing are needed. No batteries, why? Because the battery's internal, just like this bug light that I showed you. Code requires emergency power circuit supplied for all exit signs. So all these exit signs, unless it's got a battery inside. Okay, so if you don't have a battery, you're just using one that's powered up, you know, then you're going to have to put in some type of system to run these, whether you use batteries or you use a generator. Emergency illumination section 716 includes egress lighting, illuminated exit signs, and all other necessary luminaires. So if you're putting in emergency lighting to light up, and you have a generator and it lights up lights in the room, it lights up lights in the hallway and in the stairwell, and then the code requires you have to have this. This is egress. What this is, the egress is so you can exit the building. Okay, this is all so you can get out of the building. If you're using batteries or emergency lights that have a battery inside, and then that light's got to stay on for an hour and a half so people can exit. You got a generator, generator's got to run. It's got to stay on at least an hour and a half. You know, so you got to make sure you're checking the levels on the fluids so the generator runs for at least an hour and a half. So that's all size, and you size the generator to turn on. Again, like I showed you yesterday, we only have a sub panel that controls certain lightings in the hallway, certain lights, like one light in every room, lights in the hallway, lights in the stairwell, and then maybe some outside lights so people can exit, and then they're outside, they're not in the dark in case it happened at night. Okay, and any other necessary luminaires. So luminaires, hallways, stairwells all got to be lit, hallways got to be lit. What does all this do? It just helps to create, so you're not creating people don't get panicky. Testing and maintenance. NEC section 703. Let me get my closer a little bit. Let me go back. Should have just, I'm getting ahead of myself here. Standby power. Oops, wrong way. On the exit side it says both OSHA and NFPA. So OSHA is the Occupational Safety and Health Administration, and NFPA is the National Fire Protection Agency, have requirements for exit lights. These requirements extend to all places of employment in both new and existing facilities. Neither OSHA nor NFPA require exit lights to be supplied by emergency power. However, code considers exit lights an emergency lighting equipment and requires that they be supplied by emergency power circuit. So on page 217 you have the exit sign that's there, and then you have the bug eyes that are up on top. You got the two pictures on figure 15-16. It says battery pack emergency lighting may be plugged into any regular lighting brand circuit provided it is not a wall switch. In this office setting, these emergency lights are installed flush and with a drop seating and LED charge light test button and easily accessible. So again, this one would have a test button at the bottom. Push the test button, the exit light would come on, and these two bug eyes would come in. Okay, so you can use that instead of an emergency power. Guess what? You've got a battery backup at the emergency power. Emergency illumination, I was talking about the 716, that was the code. The it says, according to section 716, emergency illumination shall include all required means of egress lighting, illuminated exit signs, and all other luminaires specific as necessary to provide the required illumination. Okay. Testing and maintenance. 700.3 requires that equipment used as emergency power equipment be tested periodically. The authority having jurisdiction shall conduct or witness the system testing and decide on a set schedule for testing periodic maintenance. A written record must be kept. Okay, so that's why I was reading off the instruction sheet. Okay, so this is where the instructions. The code tells us is follow the code on what was it, 100 and drew a blank on that, 103 I think. Well, it says for installation we install it according to manufacturers. Well, guess what? For maintenance and everything else, we also follow the manufacturers. An inspector may came in and change that, but at least we have a blueprint for what we got to do. So this one says every 30 days, test it for 30 seconds. And once a year, test it for the whole duration, 90 minutes, which is an hour and a half. Okay, if it doesn't stay on an hour and a half, you got to change them out. Keep a written records. Test emergency power equipment periodically. Keep a written records. When I was working in the hospital, we had to do generator test, and we logged down when I did generator test. Guess what? Once a month, I have to walk through all the patient rooms and do a GFI test. Okay, and I go back and write it down in a log. I had a log for doing a GFI, testing GFIs. If I change one out, I would write down that I have to change GFI here, 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 wherever I changed out GFIs. I also have to do a strength test on all the receptacles in the hospital. So we had a little plug thing with a spring, and it showed me the strength test. When I plugged it into the receptacles, pull it out, and what was the release, what was the thing on the release. So if I had a certain release, I can't remember it right now off the top of my head. When I had it, it didn't meet that release, I had to change out the receptacles. So it's a test that we have to do, and it all has to be logged down. Why? The authority having jurisdiction can always come back and test it. Or you have another authority, like in the hospital, we have people come in and do inspections, and then they go through all our records of all the tests that we do. So even it can be in a regular building. Why? Because they want to make sure if fire department comes in, okay, fine. Because the fire department usually tests buildings too. So they come in and they want to see your log of where you're doing to make sure everything is safe. So there's where the authority with jurisdiction will conduct or witness test a completed system after installation and periodically afterwards. So again, you're doing a new building. Okay, all this is tested ahead of time. Inspector will come in, okay, fine, is that light working? Yes, and he'll go around and he start testing. He wants to make sure that you already tested everything. When I've done some houses, inspector comes in, he's got a little plug tester and he's testing, he's checking. Okay, plugging into a GFI, making sure it's tripped. A lot more than what they used to do. Standby power systems. Standby power system serves loads that are not life-threatening in the event of a power failure. The code recognizes two types of standby systems: the legally required and the optional. The transfer of power from the normal source to the emergency source must be automatic or legally required, and standby. For optional standby systems, the transfer may be automatic. Okay, so if I have a legal required, I got to have an automatic transfer switch. Turns on and off. Okay, what's legally required? Well, hospital, you got patients. Okay, you got life-threatening situations. They got to be protected. Optional. What's optional? Your home. You know, the mini mart in the corner. That's an optional. You know, gas says power goes down. Hey, I want to make sure my stuff stays cold. I want to make sure I can stay in business. Especially they rely on the computer. They got a cash register that relies on the computer. Guess what? They can't work now. You know, power goes out. They start closing doors. Hey, everybody get out. Close the doors. They got a generator. Now they can continue to stay in business. Legally required systems. So legally required standby systems, as the name suggests, is an emergency system supplying loads required by law in the event of a normal power loss. The load supplied by the legally required standby system could create hazards or hamper rescue and firefighting operations. When normal power is interrupted, some loads that may be supplied by the system include the following. So your heating systems, that's what, you got to keep the heatings going. Ventilation and cooling. Sewer systems, if you got pumps that suck because it's going down to the basement, you got to come up 3 floors. Well, somebody goes use this thing, you got to go on. And lighting, people can exit. And that is all in Article 701, legally required standby systems. Emergency power is Article 700. Legally required is 701. And the optional is 702. Okay? Optional standby systems. Not intended to prevent hazards, protect property and business operations. It can be automatic or manual. And these are all in Article 702, optional standby power. Okay, an optional standby system are not intended to prevent dangerous or hazardous situations. They intend to protect property and business operations. These systems provide power to selected loads by either manual or automatic transfer. Typically, the following loads may be included. So you have a refrigerator, the heating unit, computer, data processing, communications, manufacturing, alarm systems. Okay, manual transfer switch can be used on an optional standby system. It says manual switches should only be used in a situation where operating personnel are present and supplied load is not critical. The need for continuous service is becoming more and more important, especially with the expansion of computer use and more sophisticated communications. It says optional standby systems are addressed in Article 700, optional. Okay, going back to these optional. What is another optional when we're talking about batteries? You know, here I gave you a little drawing where you got the charge controller, you got the batteries, you got the inverter. Well, they have what's called a UPS. So this is the system. Hold on, let me. There is a big variety of UPSs. Okay, so you have your data processing. So you got these small ones. These you can buy them at Costco, Fry's, or whatever you have. Your little ones, and you plug in. How many amp hours? Depending on the amp hours, how many watts you have. So this is an inverter, charge controller, inverter, all in one, and the batteries. So it's all internal. I see people buy these and then they go bad and they throw them away, not realizing they can change the batteries on the inside. But you'll see them a lot in a data processing. I've seen some huge ones. And they come in there. Why? Well, the system goes down. They don't want the computer systems to go down. They may have certain things on these computers and you got to take care of. Okay, so these are uninterruptible power supplies. They call them UPSs, uninterruptible power supplies. There it is right here. Uninterruptible power supplies, UPS. And they make them in all, there's a bunch of different manufacturers, and they make them in. You size it according to what you need. The batteries, how many amp hours do I need? Okay, over here I've got 4,500 amp hours. If I needed one, I need at least 9,000 amp hours. That's taking it to 100%. You usually don't like to have it where there's a word they use is depth charge. So how far down do you discharge it? Depth of discharge. Depth of discharge. So let's say I only want to take it down 15%. I only want to take it 50% over a 2-hour period. So now what I want to do is I want to make sure that I can get this for 4 hours. So I would size it for the 4 hours, and then that's how I size. So I got how many amp hours? So I got 45. Here, let me do it real quick. 4500. Let's say I'm using 24 volts. A lot of these are 12 volt. 12, 12, 12, da, da, da. So 750 amps. Okay. So times 2. So I need 1500 amp hours to give me these 4500 watts at 120, because my circuits are 120 volts. So these will convert them over. They'll have an outlet on them. They come in, or I can tie them inside, because I'm running 120 volts. Always have to remember, you got to convert it back. If you're using 12 volts, so I came up to 750 amp hours. Okay, 225, 225, 850. So it's 750 amp hours to run this for 2 hours. Okay, so if I wanted to run it for 2 hours on a battery, but I want to make sure my battery doesn't get more than half. Okay, now I got to double it. So that way, in case power goes off, comes back on, and it goes off again, at least I still got, before the batteries have a chance to charge up, I still have that extra. Okay? So, uninterruptible power supplies. When you all get out there in the field and you start working and you start putting these in, why? Well, they got a database that they don't want it to go down. You know, somebody has a database, they don't want their database to go down. Or they have their telephone systems, they don't want the telephone system, whatever it may be that they need to stay on, they put these in. You know, we have a lot of people put them in with generators. So they have equipment that can't turn off. We do generator tests. So when we do the generator test every month, okay, us switching over, because they're plugged into normal power, when we switch over, that power going off and power coming on, well, that computer or that piece of equipment or that computer could shut off. And sometimes they say it takes longer to turn it back on than it does for it to go off. You know, so they put a UPS in to handle that on, that off. Why? Because the UPS power is always there. Okay, so if power blinks, it's not going to change it. Why? Because it's coming in off the battery, it's coming in off your electricity, going to a charger, charging the battery, coming out of the battery, going through an inverter, and changing it back to 120 volts or 240 volts, whatever your voltage is. Okay, but it's all going through the batteries. Unless the batteries go bad, when power goes off, and then you're screwed. Yeah, so all it's doing is your power coming in off the utility. All it's doing is charging the batteries. The other side, the output, comes off the batteries. So there's interrupted power. Guess what? It's only the batteries that aren't getting charged. Okay, same thing with these. Okay. All right. I'm going to send you an assignment for this, and then tomorrow, for tomorrow is going to be your test and your review questions for chapter 15. All right? Y'all have a good one.